Alright, let's look at some of the issues we talked about in class today. Remember, we started a brand new unit today looking at systems of equations, and we're solving those graphically. We will be looking at types of lines created, which tells us also the types of solutions, or the number of solutions, excuse me, in my systems of equations. Remember, a system of equations is exactly what it means. It's a plural from what we did last unit, where we have more than one equation, and we're going to be looking for the types of solutions and the number of solutions. So just kind of a recap from what we talked about today. When we look at these problems, the first thing we want to look at is we want to check the slope. And then the slope can either be one of two things. The slope is going to be different, or the slope can be the same. Well, if the slope is different, then it makes it really easy for us. Automatically, we know those lines are going to cross somewhere. And if they cross, then the lines are intersecting lines, which means they have one point in common. That means they will cross somewhere at a certain point, which means they will have one solution. So the slopes are different, intersecting lines, one solution. Well, if we check the slopes and the slopes are the same, well, then we have to check the y-intercepts. Okay, let me back that off just a second. Okay, then we have to check the y-intercept. Okay, and the y-intercept is going to tell us a couple of things. It can be this, just like with the slope, it can be different, or it can be the same. Not same, excuse me, so this should be the same. Alright, let me fix this where it's pointing to where I want it to. Okay, so the slopes can be, the y-intercept different or the same. Well, if the slopes are the same and the y-intercept is different, then that lets us know that our lines will have a different starting point moving in the same direction, which means they will never touch each other. And the types of lines that never touch each other are parallel lines. And if they do not touch, that means they have no points in common, which means they will have no solution. Which means there's nothing that can make not one point, any point can make the two equations equals. And remember, that's the no solution symbol. Well, if the solutions are, let's go back up here now, if the slope is the same, the y-intercept is the same, well, we have the same line, and those types of lines are called coinciding, which means they are going to be the same line. You're going to look like one line, and what that tells you is I have infinitely many symbols of solutions, please, to the equation. Okay, which means there's my infinite symbol. Remember, what that means is any point on the line will be able to solve both of the equations. Okay, it makes both of them true. All right, so let's kind of look at some problems real quick, and just kind of what I want to do is go through these without graphing them, and we'll talk about a few of them. Okay, so let's go here. My first equation, let's just take this set of system of equations right here. Let's say I have two equations. One of them says y equals 1/2 x plus 3. The other one says y equals 2/3 x plus 4. Well, the first thing I'm going to look at, according to my chart on this table, is I'm going to check the slope. And if I look, what I notice is the slope here is 1/2, and the slope here is 2/3. So they are different slopes, excuse me, different slopes, so that lets me know the lines will intersect and I will have one solution. Well, right now I'm not asking you what is the solution, I'm just asking you what type of lines and how many solutions are possible. So for this system, I would have the types of lines are intersecting. Again, that's going to let me know it intersects somewhere on the graph, I just don't know where right now, which means I will have one solution, because if they intersect, they will cross at one point. All right, let's try this one. What if I give you something like this? What if I give you y equals 7x and y equals negative 7x? Well, again, remember, we want this to be in the slope-intercept form of y equals mx plus b. Well, here, I'm really not concerned yet with the b, but if we want to put it there, you can go ahead and add the 0. Well, if I'm looking again, I'm looking at my slope. Positive 7 and negative 7 are two different numbers, so that means I have two different slopes. So again, I have intersecting lines, one solution. Okay, so you see how it works? Just check the slope first, then check the y-intercept. What about this one? What if I had something like y equals 7 and, not y, excuse me. What if I had something like x equals 3? Well, if you'll think about this, if you remember, this one is a vertical line and this one is a horizontal line, so they're going to cross somewhere. But by the definition, if I look, if I know the slope of this line is a horizontal line, I know the slope of this one is 0. Well, this vertical line has a slope that is undefined. So now automatically 0 slope, undefined slope, automatically I know now that those lines are going to cross somewhere and have one solution. Okay, so just check your slopes and see how it works. All right, let's see. What if I do something like this? Let's see. What if we go y equals 3/5 x minus 3? And my other one would be y equals, let's say, 6/10x plus 3. Okay, well now at first glance I'm looking here 3/5 and 6/10. You might be tempted to say that this would be one solution, but if you'll think about this, remember we've always got to try to reduce this slope to the lowest form. Well, this fraction 6/10, I know I have a common factor of 2, so I can reduce that by 2. So 6/10 becomes 3/5 x plus 3. So we've taken this equation now and we've changed it to this. Well, now I can look. Now if I check my slopes, now I notice I have the same slope but different y-intercepts. So I have the same slope, but I have different y-intercepts. Well, let's go back to our chart and see what that tells me, what kind of lines we're going to have, what kind of solutions. Well, if I check my slope and they are the same slope, we follow the flow, get to the y-intercept. Now we got to say, all right, now I have different y-intercepts. So same slope, different y-intercept, lets me know parallel lines will have no solution. So for this one, same slope, different y-intercept, I have parallel lines with no solution. Please remember, guys, this is not 0. This is no solution. 0 and no solution are two different things. 0 is an answer. That means that 0 would be the answer for the problem, where no solution means there is not an answer. Okay? All right, let's try one more, a couple more. Let's see. What if we did y equals 3x? Maybe back. I'm going to change that. Y equals 3x plus 9, and y equals 9/3x plus 9. Okay, again, you might be tempted to say, wait a minute, that's two different slopes and it's going to be intersecting line, but let's check it again. If this was in lowest form, this one's not, so we've got to reduce this one. So if I reduce that, the greatest common factor would be 3. I would have 3/1x plus 9, 3/1x plus 9, which is going to reduce to 3x plus 9. Well, if you look now I have the same slope and I have the same y-intercept, right? Okay, so if we go back to our chart, same slope, same y-intercept, coinciding lines, infinite solutions. So we have coinciding lines, and we have infinite solutions. So you guys, you see, we can look at these equations, and before we even graph them, we can tell the types of lines that are going to be created. They're either going to be intersecting, parallel, or coinciding, and we can tell the number of solutions. Now again, here, I'm not going to ask you what is the solution. I'm asking you how many solutions are possible. We're going to move into that in just a minute, but I want to look at that one more time. So same slope, same y-intercept, the lines will be coinciding, so when you graph this, it would look something like this. Remember, we talked about this in class. It looks like you will have one line laying on top of the other. So you'll actually see what, on your test, it'll be black and white. So, but it's going to look like one line laying right on top of the other. Okay? So that's why we call it coinciding. All right. What if I go over here? Let's try to do one. Let's graph one. What if we say y equals 3 over 2x minus 5 and y equals negative 3 over 2x minus 5. Okay? Well, if you'll look, 3 over 2 and negative 3 over 2 are two different numbers. So right now I know for a fact these lines should, before I even graph, they should intersect somewhere and should give me one solution. So let's see. Let's do this one, even though I wrote it in red. Let's do it in blue. So we're going to start at negative 5. And this tells me to rise up 3. And since it's a positive slope, I'm going to run 2 to the right. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay? And then let's go back over here. 1, 2, 3, 1, 2. All right? So there's my blue one, and now we'll do this one in red since we've already got it done. Let's do this one. This one says I'm going to start at negative 5. 1, 2, 3. But now I'm going to run to the left because it's a negative. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2. So I just remember to keep that. It's like a dance step, right? 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And when you can't dance this way, let's dance back this way. 1, 2, 3, 1, 2. And I can't dance anymore. So what I'm going to do is I'm going to draw my line. And y'all know my lines are not straight. So there's my red line. There's my blue line. And I'm sorry they're not straight, I know. Okay, but if you'll look right here, this is the point of intersection where they cross. So that means the solution to this system is 0, negative 5. Okay, now remember we talked about checking this. Well, if I want to check this, I can plug in. Remember, this is my x, this is my y. It needs to be true for both to be a solution. So let's see right here. 3 over 2 times 0, which is my x value. 3 over 2 times 0 minus 5 should give me negative 5. So when I put in 0, I get out negative 5. That one's true. So when I put in 0 here, I still should get out negative 5. Well, negative 3 over 2 times 0 is 0. Minus 5 is negative 5. So it checks. Okay, so there's my one solution. I'm sorry, yeah, one solution, x equals 5. Okay, so that's one solution. Let's do another one solution. What if I was to do something again? Let's do one like we did a while ago. What if I give you x equals, let me, hold on. What if I give you x is equal to 3 and y is equal to negative 7. So y is equal to negative 7. All right, so let's graph it this way. We're going to say this is my red and this is my blue. Well, before I graph, this, I want to make a little prediction. I'm looking here, I see a horizontal line and I see a vertical line. So I should have one solution, but I also know this is undefined and I know this is 0. So my lines should intersect somewhere. Okay. Now the good thing about this one is, before I even graph this, I know what my intersection is because it's telling me my x value and it's telling me my y value. So I should cross, if I graph it correctly, I should cross at 3, negative 7. So let's see. All right, here's the red. So x equals positive 3. So we're going to put a dot here, and I'm supposed to change colors and it didn't. So x is positive 3, which means I'm going to draw a vertical line. Now I can put a bunch of dots if I need to. Okay, but since I'm crossing at vertical 3, I'm just going to go ahead and draw my line to the best of my ability, which is not really good today. Okay, so here's my vertical line. Now let's go to the blue line. Well, the blue line says a horizontal line at negative 7, or I'm crossing the y-axis at negative 7. So if I go across here, and what I noticed a while ago, what did I say? There's my point of intersection, and it is at 3, negative 7. Okay, so let's check it real quick. This is how we check this one. X is 3, yep. Y is negative 7, yep. So it checks. Okay. All right, let's do a couple more, and then we're going to call it a day. All right, so what if I give you this? What if I say y equals 2x, and what if I say y equals 6x? Okay, so hopefully you'll see right now we should have some kind of intersection here, uh, and you should be able to see that it's going to cross at the point of origin. I'm sorry, yeah, it's going to cross at 0, 0 because neither one of these are showing a y-intercept, which means I've got to add one. So hopefully you'll learn to see this, but right now I should have intersecting lines should cross at 0, 0. Let's see. I'm going to do this one in blue, and we'll do this one in red. Okay. All right, blue is, so I'll start at 0, up 2 over 1, up 2 over 1, up 2 over 1, all the way across my board until I run out of room. Then we go back the other way. Okay, down 2 over 1, down 2 over 1, down 2 over 1. All right, let's do the red. This one says start at 0 but go up 6, right, and over 1. Oh, I forgot to put my 0, didn't I? So we start here, up 6 over 1, and I can't go any more, so let's go down 6 over 1. So my line should look something like this if I can draw it straight. Tell you what, let's do this. We can do it. I know I can draw it straight this way. Hold on. We know we can draw it straight this way. So here is the wrong color line. So we should have a dot right there. Okay, and then let's draw the blue one. And if you'll notice, they should cross at the origin, which is right in the middle, right? There it is, okay? So if we check this, again, my point of origin is 0, 0, right? Well, 6 times 0 is 0 plus 0. Gives me my output of 0, okay? So just check, go back and check it, all right? Let's check, let's do a couple more. What if I give you, let's get rid of all this, okay? What if I give you something like this? Y equals 2/3 x plus 4, and y equals 2/3 x minus 4. Well, if I'm looking at here, if I look really quick, and I can also still use my graphic organizer if I need to, right? Well, what I'm looking at before I even start, same slope, different y-intercepts. These should not touch because I'm starting in two different places. So let's do this one in red, and we'll do the other one in blue, okay? So since I'm on blue, let's go ahead and do blue. So we'll start at -4. We'll go 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. We run out of dance room. Let's go back the other way. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. There's the blue. All right, let's switch to the red. Okay, so this says start at +4 and go 1, 2, 1, 2, 3. And all I'm doing again is counting my rise, which is my run. My rise is the numerator, run is my denominator, and since it's positive, I'm running to the right. Well, when I run out of room, I got to come back and go the other way. So the opposite of up to right 3 is down to left 3. Well, if you'll notice, none of my dots touch. So here I have parallel lines with no solution. All right, let's look at an infinite solution real quick, and then we're going to stop. All right, so something like this. Let's say y equals 3/5 x minus 2. All right, what about this if I say y equals Let's see, 9/15. So 9/15 x, trying to get this for you guys, 9/15 x minus 2. Alright, so we're going to do this one in red, and we'll do the other one, hopefully, in blue. Okay, so we'll do this one in blue. Well, let's graph the red one first. So we're going to start at -2, and we're going to go rise 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Down 3, left 5. Alright, there's my red one. Now let's look at my blue one. Well, I can start graphing, but guess what? This is too big for my graph, isn't it? But guess what? I can look right here, and I can see I got a little work to do right here. Well, if I was to divide both of these by 3, then I can reduce 9 divided by 3 is 3. 15 divided by 3 is 5. Okay, minus 2. Well, now I look, same slope, same y-intercept. So what I'm going to end up doing is I'm going to start at the same point, and I'm going to have the same lines. So my dots are going to touch the same place everywhere on this line, so that what I have now is coinciding lines. Because if you'll notice, if I was to draw a red line and a blue line, it would look like one line. But what I do want to show you really quick, and I want to kind of reiterate this point to you. If I was to draw that, okay, and then if I was to turn around and draw the red on top, and I want you to remember this real quick, is because this is the important part with a coinciding line, is if I can get this thing to come up here. Okay, so what I'm trying to do, even though I know that these points that are on the line, that you can see the ones that I have actually put on here, okay, all of these would make both of those true. It doesn't matter which one of these points I pick, it would be true for both. But the same goes to say for even this point here. Even though I don't know exactly what that point is, I can say that's 7.5, -7.5, -6.5. That would be true for both because they're on the same line. Same thing here. I don't know exactly what that number is, but I know it's -3, -3 point something. So, but it doesn't matter. It's on both lines, so it would be true for both of the equations, which is exactly what coinciding means, which also means infinite. So any point, remember that line goes on forever and ever and ever in both directions. So I can actually say any point from -infinity to +infinity would make that true. Okay, so think about that, and when we're doing these problems, the first key is go all the way back here, is right here. Check your slope first, and then if it's the different intersecting lines, one solution, same slope, then you got to go check your y-intercept to determine the type of lines and the type of solutions. So the 3 types of lines are intersecting, parallel, and coinciding. And the solutions that match those are one solution, no solution, and infinite solutions. Okay? Alright, tomorrow we'll work on graphing some that are in standard form, and we'll move on to our next activity. Have a good evening, guys.